Hi everyone, today we are going to start Unit 2. We're going to do Unit 2, Lesson 1, and it's all about parallel lines and then the angles that you find around parallel lines. And so take a look at this picture. What's going on? It's kind of weird. So what you might start thinking is the ceiling and the floor are perhaps not parallel. And I think this is an optical illusion. If you look closely at the windows, they're not the same size. I think as you go farther toward the back corner where the girl with the balloons is standing, notice the square, the tile that her feet are in versus the tile that the other girl's feet are in. Much bigger. The back corner is much bigger than the far right corner, and so there's an optical illusion here, and the lines are definitely not parallel. We're going to start by getting down a bunch of definitions. Write rather small because we're going to have to fit kind of a lot into each of these boxes. So let's get started with parallel lines. Parallel lines are coplanar lines that do not intersect. Coplanar lines that do not intersect. And you can see a picture of parallel lines. If you go over to the right, you can see line M and line N. One thing that you might notice is sometimes in math problems you'll see an arrow drawn on the lines, like I just drew one on M and one on N. Those arrows mean that they're parallel to each other. If they both have double arrows, then that means that they're parallel to each other. There's also a symbol for parallel, and it's basically two tall, skinny lines. So let's make a little note of that. The symbol is basically two tall, skinny lines, kind of like that, or two tall segments. And an example of parallel lines, I could say M is parallel to N, using that picture over there on the right. Next, we're going to talk about skew lines. So skew lines are lines that do not intersect, but they're also not parallel to each other. So let's jot that down. Lines that do not intersect but are not parallel. So again, if you look over to the right, you can see an example of skew lines. So M and N are not facing exactly the same direction, so they are not parallel to each other. Another example might be, like, for instance, if I had a line that came down and hit right there and then went through the plane, maybe I could call that line S or something. Line S is also skew to M because they're never going to intersect, they're never going to touch, but they are also not parallel to each other. So an example of skew lines in this picture could be M and N, and unfortunately there's no symbol for skew. But you could also use M and S as an example of skew lines. The next term is parallel planes. This one's pretty obvious, I feel like. It's going to be two planes or a number of planes that do not intersect. So planes that do not intersect. And you can see over on the right, we have two planes. We have plane R and plane P. And so we could write something like R is parallel to P. And it would just mean that those two flat surfaces are never going to intersect. They are parallel to each other. Some more vocab. First word is transversal. So a transversal is a line that intersects two or more coplanar lines. Let's jot that down. A line that intersects two or more coplanar lines. A line that intersects two or more coplanar lines. In the drawing here, T is the transversal. So T is this line right here. It cuts through S and V. Therefore, it is a transversal. It intersects two or more coplanar lines. So an example would be line T or T. Next, let's talk about interior angles and exterior angles. When you have two lines like S and V, here's S, here's V, you're going to have some angles that are interior to those two lines. And they're going to be the angles that are between the two lines, like 4, 3, 5, and 6. So I think rather than write out the whole definition, we'll just put the examples. So angle 3, angle 4, angle 5, angle 6. The definition just says angles that are between two lines. And exterior angles are going to be angles that are not between the two lines. They lie outside of the lines. So in our case, the exterior angles, if I erase my little marks in here, the exterior angles would be like 1, 2, 8, and 7. See how they are not in between the two lines, but they are exterior to the two lines. And so I'm going to jot those down. The exterior angles are angle 1, angle 2, angle 8, angle 7. Now we're going to get into more specific types of angles. Consecutive interior angles. Consecutive interior angles are non-adjacent interior angles that are on the same side of the transversal. Let's write that down. Non-adjacent interior angles, non-adjacent interior angles that lie on the same side of the transversal. Non-adjacent interior angles that lie on the same side of the transversal. An example of some consecutive interior angles could be 3 and 6. So do you see how those are interior angles, but they're not adjacent? They don't have the same vertex. They are on the same side of the transversal. Here's the transversal. They're both on the right side of that. So an example of some consecutive interior angles would be angle 3 and angle 6. That would be a pair of consecutive interior angles. Another pair would be 5 and 4. So also angles 5 and 4 would be a second pair of consecutive interior angles. They're interior because they're between the two lines, S and V, and they're consecutive because they're on the same side of the transversal. Rather than write down the long definitions of these three, I think we'll just put the examples down. The first one is alternate interior angles. They are non-adjacent interior angles that are on opposite sides of the transversal. So alternate sides of the transversal. So an example would be 3 and 5. Do you see how they're interior? They're inside of these two lines, S and V. They're in between them, but they're on alternate sides of the transversal. One's on the right and one's on the left. So one example of alternate interior angles would be angle 3 and angle 5. They would be a pair of alternate interior angles. A second example would be 4 and 6. Those are alternate because they're on alternate sides of the transversal, but they're interior because they're between S and V. So angle 4 and 6 would be another pair of alternate interior angles. Next, alternate exterior angles. So they have to be exterior to S and V. So think about here's S, here's V. We don't want them in between there. We want them outside of there. But we want them on alternate sides of the transversal. So if we pick one, the alternate exterior angle that goes with that is 7. So angle 1 and angle 7 are alternate exteriors. Can you name the other pair? If you're thinking angle 2 and angle 8, this angle, and this angle are another pair of alternate exteriors. And finally, our last definition here is corresponding angles. Corresponding angles are angles that are in similar locations when two lines are intersected by a transversal. So for instance, 1 and 5. Take a look at 1, take a look at 5. At this intersection right here, 1 is in the upper left corner, and down here, 5 is in the upper left corner. They're in similar positions. So angle 1 and angle 5 are corresponding angles. They correspond to each other. Another example would be angle 2 and angle 6. This one over here and this one over here. They're both in the top right quadrants at their intersections. We could also do angle 3 and angle 7. So down here and here, those are corresponding angles. And finally, we have one last set, angle 4 and angle 8. Those are corresponding as well. Before we get started on the examples, remember perpendicular lines. Perpendicular lines meet to form a 90-degree angle. Remember the symbol is an upside down T, so in this case I could write, for example, V is perpendicular to S, using that picture on the right. And then another thing to remember is that vertical angles are always congruent. Congruent. And remember the symbol for that is an equal sign with a squiggle above it. So if I look at the picture on the right, I see like angle 1 and angle 3. I can say angle 1 is congruent to angle 3 because they're vertical angles. Same thing with 2 and 4. Angle 2 is going to be congruent to angle 4 because they're across from each other. They're called vertical angles and they will be the same size or congruent. And lastly, our last reminder, two angles who form a linear pair form a line or form supplementary angles. I put line, and I just made a note. Linear pairs are supplementary. That means they add up to 180 degrees, just as kind of a reminder. So an example, it's written here already for us. An example is angles 1 and 2 would make a linear pair. So you have 1 and 2. Here's your line, and it's divided into a pair of angles. Another pair is 2 and 3, or 3 and 4, or 4 and 1. There's lots of linear pairs there. Take a line, divide it into a pair of angles. So let's try this first little example here. First of all, I want to point out this extra set of arrows. This extra set of arrows here means that those lines are parallel. And it's kind of a lot of special things happen when the lines are parallel to each other. So first of all, let's use our knowledge of linear pairs and vertical angles and see if we can fill in all the missing angles on this picture. So for instance, I think about 118 right here. The one across from it should also be 118. But then if I think about a linear pair like up here, well, they should add to 180. So 180 minus 118 leaves us with 62. So this angle would have to be 62 degrees. The one across from it, its vertical angle would also be 62 degrees. If you go down below, we can also fill in these angles. Here's a 62, so the one across from it is 62. And then we know 180 minus 62 is 118. So this would have to make a linear pair right up here. They have to add up to 180. So 180 minus 62 is 118. And its vertical angle across would also be 118. Will you take a minute and try to do the other drawing? Try to fill in all of the missing angles on this drawing on the right. So go ahead and pause the video. And please check your answers, see if you got the same thing I did. So notice these double arrows. Again, it means these lines are parallel to each other. And it's kind of cool because when the lines are parallel to each other, things like corresponding angles, like this one and this one, will be congruent or equal to each other. Things like alternate interior angles, like for instance, let's see if I can erase this. For instance, these two angles, the 83 here and the 83 here, those are alternate interiors. They will be congruent if the lines are parallel. And that's what this is all about over here. So if we take a minute to fill in our missing angles, this would have to be 55 because these two add up to 180. This is 125 because of vertical angles. This is 55. And if we move down, we can fill in, and you'll notice they're always either going to be one of two answers. They're either going to be 55 or 125. Also notice the extra arrows. That means the lines are parallel. So if two parallel lines are cut by a transversal, alternate interior angles are, well, look at your alternate interiors. Here's one and here's one. See how they're both 55? So they will be congruent. If you'd rather write out the word, you sure can. Number 2, if two parallel lines are cut by a transversal, remember this thing is the transversal, then alternate exterior angles are, well, remember alternate exteriors. It's like this 55, it's on the left of the transversal, and this 55. They're exterior because they're not between the two lines, and they are alternate exteriors. They're alternate because one's on the left and one's on the right of the transversal. They're both 55. They're congruent also. If two parallel lines are cut by a transversal, then corresponding angles are, so corresponding angles are like the blue ones I'm going to draw in. So this 55 and this 55. They're in similar spots when you draw in, or when you look at them on the picture. They're both on the top left corner, and they will also be congruent. So corresponding angles will be congruent if the lines are parallel. And then last but not least, if you have two parallel lines and you want to look at consecutive interiors. So consecutive interiors, remember, they have to be on the same side of the transversal. So that would be like 125 and 55. Those are consecutive interior. They're interior because they're between the two lines, and they're consecutive because they're both on the left of the transversal. They are not congruent. Notice one of them is 125 and one of them is 55. They are supplementary. In other words, consecutive interiors will always add up to 180 degrees. All right, so this is part of what your homework will look like. They're going to give you a picture and you have to solve for a missing angle. On number 5, I see the extra set of arrows, which means the lines are parallel. And then I see these two angles right here. And I notice they are consecutive interiors. And I know something about consecutive interiors. If you look back to the previous slide, consecutive interiors are supplementary. So if I do 180 minus 51, I should get my answer, which is 129. So x equals 129 degrees. Now at the bottom of that, it should say because of, and we're going to say because of the consecutive interior. Consecutive interior. Sorry about that little glitch in the video. Consecutive interior angles. Okay, next, take a look at number 6. Number 6, I see double arrows right here and right here, which means those two lines are parallel to each other, and I need to solve for x. Now, when I look at this picture and I see the 94 up here and I see the x down here, I have to figure out what kind of angles are they? Well, they're not between the two lines, they're outside of the two lines. And the x is on the left of the transversal, this is the transversal, and the 94 is on the right. So I think they are alternate exterior angles. And if you look back on the previous slide, it says alternate exterior angles are congruent if the lines are parallel. So this one's pretty simple. X is going to be 94 degrees. And the reason I know it is because they are alternate exterior angles. Exterior. So what type of angles are these two angles? First of all, are they interior or exterior? They're interior. Are they on the same side of the transversal or alternate sides of the transversal? They're on alternate sides. So these are alternate interiors, and they should be congruent if the lines are parallel, which they are because of these extra arrows. So the 2x plus 1 should be the same size as the 105. This angle and this angle should be the same size. And if you look at them, they both look obtuse. They are the same size. So we're going to subtract 1 and divide by 2. And x equals 52. And the reason we know that they're equal to each other is because they are alternate interior angles. Will you guys pause the video, try numbers 8 and 9 on your own, try to set up the equation. Are they equal to each other? Do they add up to 180? Try to set up your equations and solve them, and when you're done, then unpause the video. So these angles in number 8 are consecutive interior angles. They're in the similar spots at the two intersections, and so they are equal to each other. They are congruent. And so I'm just solving here. And for me, I got x equals 29. Now it's not 29 degrees in this case. It's not the size of the angle. It's just the value for x. The reason I knew this is because of corresponding angles. Because corresponding angles have to be congruent. For number 9, I'm looking at this angle and this angle. These are alternate interior angles. They're both inside the parallel lines and they're on opposite sides of the transversal. They are also congruent, so I set them equal to each other. Do the algebra and solve it for x. X turns out to be 6. And the reason, or the because of, they were alternate interior angles. Last but not least, go ahead and pause the video. See if you can do 10. So what I did is I extended these parallel lines, and then I thought of this as the transversal cutting through. This angle here and this angle here would be consecutive interior angles. They are not congruent. Notice how one of them, the one down here, looks acute and the one at the top looks obtuse, but they are supplementary. So the 12x plus 4 plus the 5x plus 6 together should equal 180 degrees. They're consecutive interiors. Add your like terms. 12x and 5x is 17x plus 10. So x turns out to be 10, and the reason we figured that out is because we know consecutive interior angles are congruent if the lines are parallel. That's it for Unit 2, Lesson 1. So now you can go ahead and try the practice. If you get stuck, don't hesitate to send me a Schoology message. Have a great night.